Can everybody hear me? Do you want me to sing? No. That's a definite no. Who's never heard of FusionReactor? You lying bugger. Who uses FusionReactor? Good. Yeah, I was in Washington for the Adobe CF Summit East in April, and there was a keynote speech, and the head of the business unit for Cold Fusion, there's a room full of people. He said, "Who uses Adobe's PMT system?" So the monitoring thing that they've got, not one person put their hand up, which he wasn't impressed, actually. It's, didn't go down very well. But anyway, that's another problem. So should we wait? What are we doing for time? Got 3 minutes. Who's not German? Yes, Swiss, you are like Germans. You speak German. You understand German. Yeah. What was that? What? Share the joke. Share the joke. Who's never used ChatGPT? One? Oh, wait, stop. Whoa. 1, 2, 3, 4, maybe. You've heard? Who's never heard of ChatGPT? That was a joke. I know, but I saw you. I know you're kidding. Yeah. Good. We don't do anything with ChatGPT, by the way. But I'll explain it when we get there. Okay, 1 minute to go. It's exciting stuff. Who didn't come round to the booth to see this already? I'll see something similar. Ooh. Yeah, okay, well, that's good. Yeah, that's good. That's fine. And did everybody have a good time? Is there anybody who was upset that the bar closed last night at 11 o'clock? Good, yes. It had to be you. I was upset too. There you go. That's nothing new. Should we start? Yeah? Okay, let's go. All right. Hi, everybody. My name's David Tattersall. I'm the CEO of Integral. We're the guys who make FusionReactor. As we found out before, some of you are already customers, which is great. And today we're going to be talking about unleashing the power of FusionReactor and OpsPilot AI. Okay, so just a couple of slides about Reactor. What are we all about? Helping developers to get better insight and transparency into their applications. As you can see, FusionReactor will instantly discover errors, memory anomalies, CPU issues. It'll explain your code, it'll rewrite your code, it'll walk the dog, it'll make you a coffee. It does all of these things. FusionReactor has been around for quite a long time. We were here at the first CFCamp. We've sponsored every single Cold Fusion event since 2006. FusionReactor's got over 5,000 customers, about 35,000 production servers, and we're the global market leader for CF monitoring. So, change ahead. Software development's change, monitoring's change with it. Who's using Dockers? Good, good. So Kubernetes? Good, good. Yeah, so there's a big change. There's a move to microservices, Kubernetes, and with this, if you go back a few years or so, there was definitely a shift in observability. People talk about the three pillars, which are metrics, logs, and traces. And if you would ask Gartner, Gartner will tell you, oh, AI operations is coming and machine learning's coming. But it's actually arrived. So developers don't have it easy, at least without FusionReactor. So a couple of quick stats. According to D-Zone, 32% of developers spend about 2.5 days to isolate a production problem. The majority of that time, so 75% of it, is spent on this thing that we call mean time to know. It's understanding what is the problem. That's usually the part that takes the longest. You know very quickly you've got an issue, and usually you can fix it. Maybe it's just a couple of lines of code. But the hard part's understanding, and that's what FusionReactor's always been about. And they also said 94% of developers still use logs to find errors. Would you say that's true? Do you all use logs? Yeah. Anybody never use logs to pinpoint a problem? Don't all shout at once. Okay, well, there you go. Okay. FusionReactor's goal is to gain comprehensive coverage of your whole environment. This wasn't always the goal. FusionReactor, the on-premise version, really was very focused at application monitoring. Where we've gone to now is really capturing the whole picture of what's going on in your environment. And we're doing that in real time. We've got something called dynamic instrumentation, which I'll explain to you. And what we've just released, and we were actually the first company in the world to release generative AI into an observability solution in production. So we've gone very, very deep into AI and machine learning, and we're building that on top of these three pillars, these metrics, logs, and traces. We're doing profiling, debugging, error detection, and lots of AI. It's just a little picture just to show you. Most of you will be familiar with the on-premise UI. The screenshots there are of our cloud UI. And really, the cloud extends it, and extends it incredibly. So you've still got, obviously, we're capturing logs, metrics, or let's say metrics, resource information, SQL information. That's all the same, but we've added infrastructure, we've added log monitoring, we've added something called distributed tracing. So with FusionReactor, we're now able to instrument not only Java, so Cold Fusion Java, but we've embraced something called OpenTelemetry, and with OpenTelemetry, we can now instrument other languages like .NET or Node or Python or Ruby or Rust or Go. So we've extended it. We've also embraced open source technologies, so we're using Prometheus, Loki for logs, Tempo for traces, and we're a Gartner customer. We asked Gartner about 2 years ago, which technologies should we be using as we sort of look forward with monitoring? And this is what they said that we should do. So we sort of followed the Gartner path, and it's turned out that it was the best decision to do that. We're also embracing Grafana as a technology, so a lot of the graphing components are built on Grafana. And we've also been on the OpenAI beta for about 2 years. So OpenAI is the company behind ChatGPT, and that's what's enabled us to be, we were immediately put onto the list to get GPT-4. So that was the latest available commercial large language model, and that's what we've integrated into FusionReactor. Okay, so let's hop into the demo, because there's a lot of stuff to do. So which problems are we going to look at? So there's various things that I'm going to show you. I'm going to show you performance-related issues, where we can look at resources. We can look into external applications like databases or APIs. So I'll show you what the distributed tracing looks like. We'll look at specific DB issues. We're going to take a quick look at memory problems. We're going to do a bit of debugging. So I'll show you the debugger and an event snapshot. And then the just about anything is I'll go through and show you the AI integration and what it's capable of. And yeah, that's what we'll do without further ado. Okay, hopefully I'm able to keep a good eye on the time here, because there's quite a lot of stuff to do. Okay, so the first thing, this is FusionReactor. This is FusionReactor Cloud. So I'm going to focus on my slowest request. So you can see here this particular application. This is called Store. This is running on a little cluster with a couple of machines on it. It's a cold fusion application, but it calls out into other technologies. So if I go into here and I say, okay, so for the last period, let's take a look at the last hour here and see whether I've got some slow things running. Okay, so I've just said only show me transactions which are running for longer than 5 seconds, and I've got this products.cfm. Very typically, when you may see transactions, and very often it's the database where you've got problems. But usually, if something runs for, by default, longer than 3 seconds, we'll profile it. And in this case, you get a profile. And these profiles are very, very, very useful. And this particular profile, this is running something in Lucy. This particular thing, and I can see here that it's spending basically most of its time in this errors.cfc. And what I just did there, I clicked the profile that you've got, I clicked into it, and if I've not told FusionReactor where my code is, it will just decompile it. Okay, so it just decompiled it. In this case, I don't have the code for this available here. I do have some other code that I can show you, so we don't decompile it. But basically what this is doing is, this is doing a dump into, it's going through various directories, and it's storing data into this dump store, this dump file. And it's iterating through a bunch of directories, and that's basically what takes this here 31 seconds. So this is one way to find out what a potential problem would be, so you could profile it. If we take a different example, just let me turn that down, and then I'm going to show you a distributed trace now. So this is also this bynow.cfm. If I drill into that one, this one didn't run very long. This was 937 milliseconds. And if I take a look at the sub-transactions here, the trace, I see this was calling out to CFHTTP. It did this order processes thing, but I don't see too many other details here. But when I click into the detailed trace, this is where I do see more details. And if I open that up, this is a distributed trace, and what you can see, the horizontal lines here are what we call spans. And on the left-hand side, I can see a breakdown. This started in Cold Fusion. It did a CF HTTP call, then an HTTP post. That called out into this order controller here. There was some database work. It called out to Kafka, which was also measured. And finally, it called this the shipping processor. And you'll see this is a different color, and this is a different color because this is actually written in Node. And you can see here the telemetry SDK language is Node. So this is just showing you an example that with the cloud, we're not contained to CF, so you may also have other technologies that you're using that you'd like to see those technologies and measure them, and that's all now possible. Another nice feature here is that we can generate this node graph. So this node graph gives me the end-to-end call structure of the complete transaction. And it will highlight if you've got certain points in this that were taking longer, for example, this order processor, it will highlight it for you. Another important thing that we've got here is, like I said right at the start, with the cloud, we're not just focusing just on the application data. We're pulling in logs, metrics, and traces, infrastructure metrics. And in this particular case, I've got nothing. Let me check, see whether I've got another one. This was the demo effect. Ah, yeah, there we go. Okay, so I clicked into this order controller processor, and if we've sent logs over for one of those spans, the logs will automatically be linked. So when I click on logs for this span, I can basically see those logs here. I can open that log up. And you'll also see there's a trace link. The trace link, if we searched in the logs and I hit that log, the trace link would bring us back into this trace on the left-hand side. And we've also got a link here for OpsPilot AI. So this OpsPilot AI, I'll talk about that in a couple of minutes, but this is basically where we're linking into the generative AI component to get more information about that log. But I'll show you that in a sec. Okay, I'm going to go, so that's some information on performance, and I'm going to switch to, I've got like a funny setup that I've had to do here because the network wasn't working right for my VM. But what I'm going to show you now, this is FusionReactor on-premise. Hopefully everybody can see that okay. And I'm going to show you some of the elements, also part of FusionReactor, that we've got available to measure memory and some other resources. So if you're looking for memory anomalies, one of the things that we use, and we use quite a lot, is requests by memory. So very often you may have some transaction that runs very quickly, but yeah. Oh, I'm sorry. Yeah, sorry, go ahead.
Regarding tracing, for instance, in case, do you have any clients for web apps or for Android or for Flutter client, and will they be displayed on the trace? Like, are you caching also front-end side? Are you tracing anything?
On the front end, we aren't at the moment, but we will be.
Like Sentry does.
Yeah, exactly, yeah. So, yeah. Right, yeah. We don't at the moment, but that is supported. Basically, there's a library that's been made available through Grafana, and that will allow us to do front-end components as well. So. Yes, that we would be able to do, yeah. I mean, that's the way that you do it. You inject the trace ID and then follow it down the chain. And as you follow it down the chain, as long as you adhere to the rules of how to do it, it'll render. That's the cool thing about all that stuff, that it's very, as long as you play by the rules, it generally, it all works. Yeah, sorry I didn't see your question. I was like wrapped up in my own little world, in my Fusion Reactor world. Okay, so what was I going to show you? So I was showing you this generate JSP. So basically, this thing used, I don't even see that, 3.3 gig or 3.23 gig of heap. And when I drill into that, I can see, I know that this was building a database. So I can see here, I got a bunch of create tables. We can see the total time spent for each of these SQL commands. When I'm doing, bless you, when I'm doing a bunch of inserts here, I can see how long those were taking, how many rows were impacted by each of those SQL commands. So there's a lot of information there that we can see. Of course, we can also go into here and we can look at, I can say, show me the longest requests or the slowest requests. So a lot of people use these capabilities to say, okay, what's running slowly? This is a very, very typical usage model, and I appreciate I could probably increase the font here of this if I knew how the old shift control doesn't seem to be working. But anyway, okay, so that's what we can do there. We can also look into JDBC history. So I can see all the transactions that have been run, and similarly, I can look for longest JDBC transactions and slowest JDBC transactions, which is also very useful. Transactions by memory is also a really, really useful feature. You may be calling something, have some SQL inside a transaction, and it's using a ton of heap, but you never knew. And with this capability, this will basically show you exactly how much heap is being used per transaction. So that can be very useful. Okay, let's go into some other memory stuff. We've got something called the heap histogram. Has anybody here used JVisualVM? JProfiler? Okay, a couple of the Java guys, yeah. Rene, you, maybe? A bit, a long time ago in a land far, far away. Okay, so what you're looking at here, if you could see that, I'm not sure how good you can see it, this is basically analyzing the heap in real time. This capability is also in tools like JProfiler, JVisualVM, but you couldn't run it in a production environment. Why? Because of the way that the instrument memory. We're doing we've built this on a sampler. Normally they will have built it on, they're doing class instrumentation to get the memory components out, it just takes too long. But this is suited for production, also gives you very, very good results. What you can do here is you can take a snapshot, and what you would do to look for memory anomalies is basically compare points in time in memory. So I just took that snapshot now. I took a baseline earlier, and what I can do is I can perform a diff on those 2 points in time. I'm instrumenting every single class which is instantiated on the heap, so I can get an instant picture of how much memory was allocated per class and the number of objects. That can be quite useful. Okay, what I'm going to show you now is just real quick is I am going to generate an error, hopefully. So this is, okay, there you go, divide by 0. And if I go into my divide by 0, if I take a look into the error history here, this was the transaction that just ran. And if I click, this has got 2 links on it, event snapshot and error. If I click on the error, this is the stack trace for the transaction that was just executed. And this is divide by 0. Again, hopefully, and that's difficult to see, right? Yeah, it's a bit difficult to see. Okay, that's my code up there, and I'm taking X and I'm x is equal to 10 divided by y, and y is, it's on a rand range, so y was 0 in this particular case. If I click on that, I can set a breakpoint. So think about this, you're in production, you just set a breakpoint in production, so you're going to halt your production environment. Woo! Who's terrified by that? Right. 4 people are terrified. All the rest of you don't care. It's cool. Okay, so yes, can anybody tell me why wouldn't you use a debugger in production? What's the main reason? Pardon? Right. And any other reasons? There's 2 main ones. That's number 1. Number 2, performance. Normally, the debugger will put the engine into debug mode, slows it down by about half, and it'd kill performance. We don't do that. And to answer your question, we've got a controller in place to stop the debugger being called multiple times. So, and I can just show you that real quick. So if I go into here and I'm going to edit. So this is that particular breakpoint, and I can see which file this was in, the line number, trigger on. I can set a condition here to only trigger the debugger on a certain condition, like if some variable is not initialized or something, I could do that. And it's going to fire 1 time. Trigger fire count is 1. So this means it's only going to fire for 1 single error, and if I run that again, you can see that tab's spinning, and if I go back into FusionReactor, I've now got this bug up in the top. And this down here is, I know you can't see it because it just looks like a blur, but that's actually the thread. And if I click on the debug icon, I'm now inside a debugger, inside FusionReactor, inside production. And it's showing me my CF code because I told it where my code resided. So this is a full-blown debugger. You've got here access to all the scope variables. I've got access to the complete stack frames here down the side. And I've got access to all the scope variables. In this case, y is equal to 1. If I set y equal to 0 and I resume that, then hopefully an error occurred. So what we just saw there was I set a breakpoint, I jumped into it, I changed a variable on the fly, I resumed execution, and I had an effect on my application.
What's the penalty on performance?
It's absolutely negligible. And the reason for that is because we've coded directly at the debugger through something called the JVM TI. It's the JVM tools interface. We wrote it all in C. It is very, very, very performant. The thing that kills it, usually with a debugger, is that you put the JVM into debug mode. That's the thing that
And on tracing, considering performance on tracing, you are running some kind of sidecar together?
No, we do it based on samples. What we're actually doing there is we're taking, you might think this is wild, we're taking stack trace snapshots. Stack trace is a very fast operation, and we're aggregating the data from the stack trace snapshots to build the profile. It turns out it's a very accurate way to do it, and even with as few as 5 samples, a sample is about a millisecond. So with about 5 samples, you still get a pretty good image of what's going on. Obviously, the more samples you have, the more accurate it is, but it's still a very performance action. Okay, so I'm going to jump in now. I'm going to show you some of the AI integrations. I think we can see that a little better. So here, these are various dashboards that I've got available. And I can see these are log files here, and up at the top I've got looks like it's an Nginx error, and if I click on OpsPilot AI, let's see what it's doing. So in the background, for everybody who's familiar with ChatGPT, which we don't use, by the way, You build, when you ask a question, you build a so-called prompt. And the prompt contains context about the question that you're asking. If I said, what's the weather like today? And somebody says, oh, it's sun shining. But then I said, oh, I don't mean here, I mean in Paris. Oh, and I mean last Tuesday. Then, I'm focusing the question down. And what you can see here is, in this particular case, there's a file missing, but the OpsPilot, what we call it, is analyze that, and it's basically going through the steps that you would need to correct that particular error. Okay? So, and for somebody, I mean, I've spoke to a lot of people at the event over the last few days. Certain types of issues, you might think, oh yeah, a missing file, okay, check permissions, check its location. That's pretty trivial. Yes, it is trivial, but I think the interesting thing here is that it goes through the various steps. So for somebody, if you're a junior DevOps, engineer, then this could be very useful. Let's take a different example. So if I go into here. And, sorry, another quote, was there a quote? Sorry, yeah.
That's obviously right now only available in the cloud.
This is only available in the cloud.
For EU customers, it's probably not going to be, for example, for us, it's not an option to transfer the data containing IP addresses and cookies and stuff to the cloud because of GDPR.
Okay, well, we're in Europe. The server where this is hosted we're hosting on Amazon, AWS. It would be possible for a transaction like that, we're using, for that particular option, we're using GPT-4. So that information is being sent to OpenAI. It's through the commercial API that we're using, the paid-for one. According to so we've got a data processing contract with OpenAI. We've got to adhere to GDPR. OpenAI have in their terms and conditions that they will hold that data for 30 days only before deleting it. And they would never look at that data unless there was some reason that we were doing something illegal.
Okay, but for customers who decide that's still is there a way to enter your own API key for OpenAI to
In theory, that would be possible. We don't have that coded, but if customers come along and say, we want you to use our key, then we could do that. I mean, I'll come on in a little bit to where this whole thing's going with AI, and then maybe that could be a point to talk about. Okay, let me show you another example. So I've got here a little CFM page. This is called poorperformance.cfm. I wrote it, and it is particularly rubbish. Again, we've got the profile. If I click on the run page, this time I'm seeing the actual code because I've told FusionReactor where my code is. If I select that and right mouse click, what you can see here is a menu is opened up, and these are different types of prompt integrations that we've got. So you can see I could either debug my code, I could explain it, so I could ask OpsPilot to explain the code that I've got. In this particular case, I know what the code does, and I don't need to debug it, so I'm going to suggest optimizations. And what it's doing now, we're building this prompt, and the sort of the secret sauce in a lot of this is the prompt creation. So when you're accessing a large language model, the more accurate you make the prompt, the better result you'll get. So we're using information in the background to enhance the prompts so that we get much better results. So in this particular case, It's identified what we need to do, so we need to, basically I was doing something in a loop which I shouldn't be doing, so it's identified that, it's asking me to use CFset, it's asking me to buffer my data, and here is an optimized version of the code. So it actually took it and rewrote it, and I've run this, it runs fine, you know, I've done a lot of examples. Every now and again you'll get something that doesn't run perfectly, but usually it just runs. And yeah, this optimized version reads the file once, stores log entries in a buffer, and writes the buffer to the file in a single operation after the loop. So that's quite interesting. Another thing that people struggle with is analyzing stack traces. Stack traces, obviously, you know, it's showing underlying Java, and they can be a bit tricky. And this example here, if I click onto the errors, here I've got a stack trace, and again, I've got the link to OpsPilot AI. If I pass this one in, so this is taking the complete stack trace together with the prompt, and in this particular case, this is there's a no dialect mapping for this particular JDBC type. It's identified that error. It's using the information in the stack trace for that, and it's coming up with suggestions of how to fix this issue. So again, it goes through, it's explaining it to you exactly what the error is, outlining basically step by step what you need to do. And it's also, in this case, providing the code, register the customer type in your Hibernate configuration. It explains exactly how to do it. And yeah, goes through step by step. Anybody got any questions about that? Anybody worried about that? Maybe a little. Pardon? For too long. Okay, it's you know, like I say, I've been sort of demonstrating it now for a couple of days. It's quite. Some people look sort of really worried. I think it's like anything. If you know, things are changing. Yeah, the world's changed. I think the introduction of AI and the introduction of large language models, generative AI, this is it's the biggest thing since the internet by far. And if you think about it from a time perspective, we're on the first day in the first minute. You know, we're right at the very start with this. So there's going to be a lot of stuff happening. Obviously, what you want to do, what I've showed you there, is individual touch points of where you can get value out of the AI inside your application. What I'm showing you now is I'm looking at data across my whole application, and I've highlighted an anomaly. That's the big red line in the middle. And down below, we've got the so-called matrix profile, which is exactly where we believe that anomaly to be. So part of what we want to do, or part of what we've done, actually, because we've sort of done it already, is not just have the generative IT AI side, but also combine that with machine learning. And what you're looking at now is this is a heat map of your whole application. You can see down the right-hand side, we've got things like we're analyzing memory, we're analyzing CPU, we're analyzing the database, we're analyzing application errors. And next to each one of those lines, you'll see that there's a name in brackets: CoPod, ECOD, iForest, KNN, MAD. These are all machine learning algorithms. And what we found was if we only use one algorithm, you get a certain angle of a result. If you use multiple machine learning algorithms, then you get a much better result. Again, at the end of the day, with machine learning, it's all about mathematics, and it's the probability of something happening. So the more we deploy, the better chance we've got of cracking the problem. What we're doing then, once we've got that, is we're building the prompt out of the context of where the machine learning algorithm thinks the problem is. So imagine, something breaks at 2 o'clock in the morning, and we say, okay, so your memory was this, you were using this much CPU, this was happening on the database, this was something on the network, these errors were being generated, and you provide all that information into the prompt, and then you pass that into the large language model. The results it's producing are phenomenal. You think about what we do when we're trying to piece things together to solve problems. This is exactly what we're doing, but very often, we miss things, we're human, and it's just not easy. That task is not easy. So that's one of the things that we're doing with machine learning. Taking that to the next level, one of the things that we discovered, that we thought about, was we thought, what's missing with artificial intelligence? And when we thought about it, we said, what's really missing is real-time instrumentation. And what I mean by that is, imagine you've got a problem, and that problem is, again, it's occurring at 2 o'clock in the morning, and let's say something's breaking, something's throwing a null pointer exception. Sorry, do you have a question? No, you're just having a stretch. That's okay. I'm very worried now that I'm missing people's questions. So 2 o'clock in the morning, you've got some event happening. It's throwing a null pointer exception. And what happens? What happens today? The next day, you come into the office, you take a look, maybe there was an error report thrown, maybe there's a stack trace, maybe you've got some additional information because you've been clever enough to capture it, but it's all maybes. Maybe you don't get the context of it, you've got to then modify your code, you've got to redeploy it, you've got to wait for that redeploy to run through, then you've got to wait to see, does that error actually occur again? I know we've all done this. We've all of us, I'm sure, certain, everybody in the room's gone through this. With dynamic instrumentation, what we're doing is when we detect that error is occurring through machine learning, we will automatically instrument at the point, because we know exactly where. I've shown you, we can detect where the error is inside the code. The AI component can look in to the code at that point and say, okay, which variables could impact this particular error? And then for those variables, it's automatically instrumenting them. So imagine in this world, what will happen is you will look at, you'll come in the morning and FusionReactor will say, oh, there was an outage last night. And here's the context of that error, with the outliers, with the variables which were triggering that particular problem, and it was here in the code. Now, obviously, the advantage with that is we caught it at the point that it was occurring. This is when we sort of knew this all along, but the realization of how to build this and put it together, this was one of the things that was the biggest aha effect that we had. Because this will make all the difference for AI in terms of observability. Observability is a very useful, it's a great way to use AI to analyze your systems. And, okay. So that's dynamic instrumentation. We call that deep. It's actually, this is available. We've built this into the Prometheus Grafana model, and we've actually open sourced it. So you can go and download it. You can see it's on GitHub here. Okay, let's go back to FusionReactor Cloud. Last thing I'm going to do, and I know we're running out of time. I'm going to ask OpsPilot a question. Can you recommend a monitoring, An application monitor for Cold Fusion. Now, we didn't tell it this, but I bet, oh, there you go. Yes, I can recommend a few application monitoring tools. Number one is, yes, FusionReactor. It's a popular and powerful application, blah, blah, blah. Oh, quick, see, Fusion doesn't exist anymore. But anyway, hey ho. Okay, the point I'm making is you can actually ask it questions. So it's got an interactive natural language interface, so you can just ask it whatever you want.
Where you mentioned your AI for observability, can you once again show the link on where you open source it? Or I can find it on...
Yeah, you can, yeah, it's github.com/integral/deep. Yeah. Okay, no problem. Okay, last slide. Okay, so that's the demo part. What's the future? The future of this is automated issue detection. This is where all this stuff's going. It's going to include machine learning. It's going to include dynamic instrumentation. You're going to be able to ask it questions. What's the status of my systems? Which alerts are firing? Yeah, what happened last night? Why did it happen? You'll be able to ask it this. We can already ask it this. I've just not demoed it to you. We're just releasing this at the moment. What we're doing is we're using, and coming back to the point before about the large language models, we're using different large language models. It won't just, GPT-4 is not the answer. GPT-4 is a current implementation of a large language model. We're using something called LangChain for people who are familiar with Kubernetes, which is orchestration for Dockers. LangChain is orchestration for large language models. And we will connect data together and using collections of data, passing the results of one question into another model. So if I ask you something, you give me an answer, I give that answer to you, you give me an answer back, I give that answer to you, and you augment it, you extend it every single time. Hopefully we'll come to a much better answer. Yeah? That's just how it is. So we're going to be using, we're already using LangChain. There will be less and less need for manual human analysis of logs and telemetry. Thank God, I hope you're all saying. And this is not, oh, all your jobs are going to be gone, but we've got to change. You know, if we put a bag over our heads and jump under the table and pretend it's going to go away, this will not go away. This is here and it's coming. And finally, the big green button. When we started with FusionReactor back in 2005, before we'd written anything really, I remember sitting with my business partner, Darren, and I said, Darren, I said, we need the big green button. He said, Dave, he said, what do you mean? I said, well, we need to push this button, and when you push this button, it just fixes everything. That was our vision for FusionReactor. FusionReactor's always been around trying to give you the answer, trying to help you. And I think where we're at now is after 18 years of doing this stuff, we are at the point of the big green button. It's here now. I feel like we've got it. So to summarize, FusionReactor will tell you when, where, and why your issues occur. AI and machine learning are changing how we interact with monitoring and what we can expect of it. FusionReactor provides this full observability of your environment. It'll also monitor other languages, logs, other infrastructure. It's available on demand and in the cloud. So if you don't want the cloud and you don't care about AI, we've got still an amazing solution that is the #1 monitor for CF that you can run on premise. Prices start from $19 to $99 per server per month. And if you do use cloud, then it's the same price for the agents, but you need a plan because we're storing data for 13 months or 30 days. with logs and 30 days with traces. The plans start at $49 per account per month, up to $249. If you spend more, we double the amount of data that you get, and you get more OpsPilot tokens. The OpsPilot tokens is the currency that we use to ask GPT-4 questions. Essential plan, you get 10 tokens. It's about 12 questions. If you take the Pro plan, you get 400 tokens. You can ask about 500 questions. Any questions? Don't all shout at once. Sir? Yeah.
So I know there are language models which just pass the personal information out of.
Yeah.
Is this plan?
No. No. We've got to be very careful what we do. We've got a lot of government customers. NASA is our customer. We've got most of the US state agencies. We have to be very, very careful about what we do. So we can't screw around with this. You know, we're not going to take any old model and pass your data to it. That is not the way to do it, really. So, yeah, that's basically it. I'm finished.